Hi everyone, I just wanted to put this video together to show you how to do the problems that are on this worksheet, the Limiting Reactant Worksheet 1, which is your homework. I want to talk you through this because this is going to be on the final exam and we are kind of running out of class time, and I want to make sure that we have class time for review. So your homework is to watch this video and to understand what do I mean by limiting reactant. So I'm going to start with this first problem number 1 on this worksheet, and hopefully you'll catch on to this really quickly. It's actually quite easy when you use the BCA tables, okay? So I'm just going to set up this BCA table, and there are a couple things missing there. There was an arrow missing there. Okay. I have my BCA table set up, and I'm reading through the problem right now. I just want to fill out the table as the problem tells me I should. So here it is. You are combining 3 moles of hydrogen with 2 moles of nitrogen, okay? Which will be the limiting reactant? Okay, now what does that mean? What we need to find out is which ingredient is going to run out first. When we run out of one of these ingredients, the reaction stops. That one ingredient that we run out of is called the limiting reactant. Up to this point in stoichiometry, we've always just been told that one reactant is in excess. Well, now we don't really know for sure which one is in excess. We've got to determine which of these reactants we have too much of and which of these reactants we're going to run out of first, okay? So just really bear with me here. I want to work through this with you, and let's solve this problem. All right, what this reaction is telling me is that if I have 3 moles of hydrogen, I need 1 mole of nitrogen. But you can see I'm given 3 moles of hydrogen and 2 moles of nitrogen. I think it's pretty easy to see that we're going to run out of hydrogen and we'll have nitrogen left over. Why? Well, here it is. If we use up all 3 of those moles of hydrogen, we're only going to use 1 mole of nitrogen. Why is that? Because the mole ratio is 3 to 1, okay? But we were given 2 moles of nitrogen, so we've got a whole extra mole that we don't even need. In fact, we're going to end up with 1 mole left over. What is the limiting reactant? It's the one that we ran out of. So this is called the limiting reactant. I'll just call it LR. And this is the excess ingredient in our reaction. Okay, well, now, if we're going to use up 3 moles of hydrogen and 1 mole of nitrogen, I can make 2 moles of ammonia, okay? So I'm going to make 2 moles, and 2 moles is how much stuff I can make. That is our answer. So let's just reiterate what was different about this problem from what we had been doing before. In other problems, I might have just said we have excess nitrogen. But this time, I'm not saying I have excess. I'm saying I have 2 moles, okay? So it's up to us to figure out which ingredient is in excess. If I used up all 3 moles of hydrogen, I will only use 1 mole of the nitrogen, okay? Anyway, let's try the next one now. All right, in this problem, I'm being given 20 moles of hydrogen and 11 moles of oxygen. And here's my chemical equation, which, by the way, we need an arrow there. Okay, I'm just going to draw a BCA table right away. And we're going to fill out the BCA table just like we would have before. There isn't really that much different about what we're doing here. It's just we're not being told explicitly which reactant is in excess. So I'm going to write down the things that I'm given. It says that I'm starting with 20 moles of hydrogen and 11 moles of oxygen. Okay? And before we start the reaction, I don't have any water made yet. All right, now, let's just try a scenario here. What if I tried to use up 11 moles of oxygen? If I used up 11 moles of oxygen, that would mean that I would need 22 moles of hydrogen. But I don't have that. I don't have 22 moles of hydrogen. So there's no way that I can use up 11 moles of oxygen. I don't have 22 moles of hydrogen. So we're going to erase that. And I'm going to use up the 20 moles of hydrogen that we are given. If I use 20 moles of hydrogen, I'm going to use 10 moles of oxygen, right? It's a 2-to-1 ratio. So I'll be left with, I'll be left with 1 mole of excess oxygen, and this is my limiting reactant. So how much water can I make? Well, for every 2 hydrogens I use, I can make 2 waters. So I made 20 moles of water, and that's my answer. That's the answer to that question. The limiting reactant is hydrogen. Okay, let's try another one. For this next one, I decided to change the equation because I thought it was a little more complicated than necessary. So I just changed this problem a little bit. I'm just going to build a BCA table now. So like I said, I changed the equation. Now the mole ratio is 2-to-1 to 2. Okay, this is what I'm given. And again, since I'm given the amount of both reactants, I've got to decide which of these reactants we're going to run out of first. Okay? So this equation is telling me for every 2 of these, I need 1 of these. So what if I use up all of the oxygen, 0.36 moles, the ratio is a 2-to-1 ratio, so therefore the amount of nitrogen that I need is only 1/2 of this. So I just need 0.18. All right, so I'm going to use up all the oxygen. I'll end up with 0 oxygen in the end. 0.89 minus 0.18. I'm going to be left with 0.71 excess. And this is my limiting reactant. So how much NO2 am I going to make? I'm going to make as much NO2 as I use in oxygen. I'm going to use 0.36. The reason for that is because that's a 2-to-2 ratio, right? So if I use 0.36 of the oxygen, I'm going to use 0.36, or I'm going to make 0.36 moles of the NO2. So that is my answer. Okay, so again, I did change the equation to simplify things a little bit. All right, so guys, your homework is going to be to finish this worksheet. There's number 4 and number 5 for you to do. And in number 5, you are going to have to convert moles to grams, or grams to moles. Anyway, you're going to need to do that conversion. All right, remember guys, very important. Whenever you're using a BCA table, the only values that ever go into a BCA table are mole values, never gram values. All right, so I hope that this was a good start for you. I'd like you to try the other 2 problems on that worksheet, okay? and I'll see you in class on Wednesday.